Good day, viewers. You are welcome. How to find these functional equations given that f of x over x minus 1 equals x squared over 2x minus 1. And what is f of 4? Before we find f of 4, we need to know the general solution for f of x. Then we plug in the value to get f of 4. So let's get into it. When we consider the solutions, I will apply the substitution method to solve this. Substitution method to solve this. So the domain is given as we have f of x divided by x minus 1 equals x squared divided by 2x minus 1. So note that the domain of this x is not equals 1. And again, x is not equals 1 divided by 2. So these two, they are not going to be included as part of our domain. If you plug in 1 here, we are going to get undivine. And if you plug in 1 over 2, we get undivine. So we have to exclude these two values. At x1 and x equals half, they are not part of the domain. Then the other numbers are the member of it. So let's try and provide solution to f of x. We are going to let x divided by x minus 1 to be equals t divided by 1. Then we make x the subject of the formula. We have x here, x here. We want to have only one x. And what to do is we cross multiply. When we cross multiply, we have x times x minus 1 times t equals x. And by opening this parenthesis with t, x times t, that gives us xt minus 1 times t, that is t, equals x. Then let's take this x to this side and transfer t to other side. Here we have xt minus x equals t. So by factoring out x into bracket of, we have this as t minus 1 equals t. And we divide both sides by t minus 1. And we get x equals t divided by t minus 1. And we are going to replace this in the functions, which the later function becomes f of t equals x squared divided by 2x minus 1. So we can use that long division or this short division. So we are going to start replacing all this. We need to find x squared and we need to find 2x. Then we coupled the two together. So since what we have is x equals t divided by t minus 1, then let's start substituting. First, let's find x squared. X squared gives us t over t minus 1 all raised to the power of 2. And again, we can also write this as t squared divided by t minus 1 all raised to the power of 2. We need to find 2x minus 1. And this gives us 2 into bracket of t over t minus 1, then minus 1. When we expand this further, we have 2t divided by t minus 1, then minus 1 over 1. By finding the LCM, we are going to have t minus 1 multiplying 1. And we have this as 2t minus open bracket t minus 1 divided by t minus 1. So here we have 2t minus t plus 1 divided by t minus 1. Then 2t minus t, that gives us t plus 1 over t minus 1. This is for the value of 2x minus 1. So by bringing this together, we have f of t equals, for the 2x, we have it as x squared, we have it as t squared over t minus 1 squared, then divided by t plus 1 over t minus 1. So this is what we have. So we have to break this thing further. So we break this further, we have f of t equals t squared over t minus 1 squared, then we multiply by t minus 1 over t plus 1. We take the reciprocal of this, that is flipping. We have f of t equals t minus 1 cancelled one of this t minus 1, and we have t squared multiplied by 1 over, this remains t minus 1 multiplied by t plus 1. Then let's change every single t to x. We have f of x equals x squared over, we have this as x minus 1, and this is x plus 1. This is the answer that we get. And if you like, you can just change this x minus 1, x plus 1, we can write it as x squared minus 1. So this is still correct, because this is just like difference of 2 squared. Since we have obtained f of x, then let's find f of 4. We find f of 4 by replacing x, fixing good x here with 4. So therefore we have f of 4 equals 4 squared divided by 4 minus 1 multiplied by 4 plus 1. So 4 squared, it means multiplying 4 2 times, and we have it as 16 divided by 4 minus 1, that is 3, multiplied by bracket is 3 times 4 plus 1, that is 5. So with this, we have our f of 4 equals 16 divided by 3 times 5, that gives us 15. And 15 is the final answer to this. Thanks for watching, and see you in the next video. Never stop learning. Bye bye.